All right, today we're going to be using the zero product rule. Zero product. So think about that. The product is the answer to a multiplication problem, and zero means that you want that answer to equal zero. So we're going to have to multiply things together to get them to equal zero, and that's exactly what we've been doing here this whole time. This is how you find X-intercepts. So zero product rule is nothing new. It's just new terminology for what we've already been doing, which is finding X-intercepts. So I gave you an example here where you have to factor it first, but in the problems tonight, it's already going to be factored for you. All you have to do is set each parenthesis equal to zero individually and solve for x. That's all you're doing here. And when you solve for x, that's your x-intercept. You're solving for the x-intercept. So how would you factor this problem? This is review. Well, you start by looking, is there two numbers that multiply to give 35 and add to give 2? In this case, they're both negative. Well, you start with the multiplying. So what multiplies to give 35 as far as whole numbers go? You just want to use whole numbers when you're factoring. 1 and 35 multiply to give 35. You can always use 1 in the number itself. The only thing else I can think of is 5 and 7. Now, these 1 and 35 and 5 and 7 could be any combination of positives and negatives. So is there any way to get a negative 2 from either of these two? Yes, 5 and 7. 7 minus 5 is 2, but in this case it would actually be 5 minus 7 is negative 2. So we want to use negative 7 and positive 5. So it's x and 5 and x and 7. So I already told you we want to use negative 7, but if you didn't understand what I was saying there, you can write down the x and the 5 and the x and the 7, and then take a look at your b term. If your b term is negative, your bigger number is negative. If your b term is positive, your bigger number is positive. 7 is the bigger number. Your b term, negative 2, is negative, so 7 is negative. B is positive. So that's the factored form of that equation. Now, zero product rule says solve for x by setting each one of these parentheses equal to 0. So you have x plus 5 equals 0, and you have x minus 7 equals 0. And this is just a simple one-step equation. Subtract 5 to the other side or add 7 to the other side, so you get x equals negative 5 and x equals 7. So those are your two x-intercepts in this problem, and you found those by factoring and then using the zero product rule. All right, which seems easy. You guys can do this one in your head. What do you put in for x? You put in negative 5, and that parenthesis equals 0. What do you put in for x here? Positive 7, and that one equals 0. All right, I'm going to get to some examples here in a minute that are a little bit trickier, but before I do, let me show you something else that you might run into. A problem like this is already going to be factored for you, but I'm going to show you how to factor it anyways. When you go to factor, you can't use the trick of what multiplies to give 35 and what adds to give negative 2 like we did here until a is 1. Right? Notice how this is just x squared. It's 1x squared. A is 1. In this one, a is 2, and that's no good, or it's a lot more difficult. So it's easier to divide the whole equation by 2, split all these numbers in half, factor out a 2. So if you factor out a 2, it becomes x squared minus 2x minus 35 equals y. And now, like magic, we're right back to the first example. Inside the parenthesis, that's the same thing we just did. So this is going to factor the same exact way, and you're going to have a 2 out in front of it. That's going to be the only difference. So it's going to be 2 times the quantity x plus 5 times the quantity x minus 7 equals 0. Now, is that going to change your zero product rule? Is that going to change your x-intercepts? No, it is not, because it doesn't matter if you multiply 3 things together, 4 things together, a million things together. If one of those things is 0, the whole thing's 0. So the 2, it doesn't matter what that number is. As long as one of these parentheses is 0, the whole left side of the equation is going to be 0. 2 is not going to change that. So we don't even have to worry about the 2. We just set x plus 5 equals 0 and x minus 7 equals 0, and our answer could be a negative 5 or it could be a positive 7, just like here. So the only reason I'm showing you this is don't panic if there's a number out in front of your parentheses. It doesn't change the answer. It's still the same answer as in example 1. All right, here's another one that is a little bit tougher to factor, and lucky for you, you won't have to factor it. It'll already be factored for you. But again, I want to do a little review. This is yesterday's. This is special product pattern, and I want to show you how to factor this. It looks difficult. You could divide everything by 4 like we just did in the last one, or you could notice that A and C are both perfect squares. A is 4, which is 2 squared, and C is 36, which is 6 squared. So you can use those square roots. You can use 2 and 6 in your parentheses. So 2x would be first in both parentheses, and 6 would be second. And then you look at the sign of B, which is 24 is positive. So both of these are going to be positive. And if you multiply, distribute the 2x and the 6 through the second parenthesis, you'll get 12x plus 12x, which is 24x. So that's how it factors, and that whole thing is equal to 0. Now this is where the zero product rule is a little bit more handy, because this is a little bit tougher to do in your head, potentially. So you set each one of these separately. Well, each one is the same, so you really only need to do 2x plus 6 equals 0 once. You don't have to do it twice. And then you solve for x, so you subtract 6 to the other side to get negative 6. And then you divide by 2, and you get x is negative 3. And if you were to check that, if you were to plug negative 3 in for x squared and for x there, this whole left-hand side of the equation would equal 0. Negative 3 squared is 9. 9 times 4 is 36. Negative 3 times 24 is negative 72. So this is 36 minus 72, which is negative 36. Plus 36 gets you back to 0, so it works. All right, you could have one more type of somewhat tricky problem, and I wouldn't even say it's tricky. It's just going to be similar to this one where you had 3 things that were being multiplied together. One of them was a constant, a whole number 2. Well, you might have 3 parentheses that are being multiplied together. You might have something like 2x minus 5 times 3x plus 4 times 8x minus 16. You might have all 3 of these being multiplied together, and it's all equal to 0. So now it's 3 things being multiplied together, 3 parentheses, 3 quantities. Whenever you have a parenthesis, there's a quantity inside that parenthesis. So parentheses are called quantities. So now you set each one of these parentheses separately equal to 0. So you have 2x minus 5 equals 0. You also have 3x plus 4 equals 0. And finally, you have 8x minus 16 equals 0. So you have to solve each one of these separately. So in the first one, you add 5 and divide by 2, and you get x is equal to 5 over 2. Now, you can leave that as your answer. You can reduce it to this. You could also say this. All those are perfectly fine, depending on what level math you're in. One of the forms may be better than the other. As of right now, I don't really care which one you use, as long as you're getting one of those 3. All right, and then the next 2 are pretty similar. So you would subtract 4 and divide by 3, so you get x is equal to negative 4/3. So that's 2 x-intercepts so far. And then the third one, you would add 16 and divide by 8. So you would get x is equal to 2. So this particular problem would actually have 3 x-intercepts, which means it's not a quadratic. Well, it's not. It's x is going to be cubed in this problem. So it's not going to look like a parabola. It's going to have 2 vertexes in it. It's going to look more something like this. It's going to be like a vertex here and a vertex there, and it's going to cross the x-axis 3 times. So that's why you don't have to factor an equation like that, because that's a little more advanced than what we're going to do this year. So this one was already factored for you. It's just checking to see if you can apply the zero product rule, if you can set each one of these parentheses individually equal to 0, and then solve for x. So that's all you're doing in the work today, is solving for x, setting your parenthesis equal to 0, and solve for x.